Hello, my name is Ryan Heaton. I'm going to give an abbreviated version of my RootsTech 2014 presentation on GEDCOM X. On June 4th, 2013, we announced GEDCOM X Milestone 1, which means there's a set of specifications that we could use to build applications on and use to actually start exchanging data. Later in the year, on September 6, 2013, FamilySearch announced a collaboration agreement with Ancestry.com to work together to make more records available online. A little bit more, over a month later, on October 14th, 2013, FamilySearch announced a similar agreement with MyHeritage, and a couple days after that, with DC Thompson, who manages FindMyPast.com. Today at RootsTech 2014, FamilySearch has a large set of partners who access the data in the FamilySearch family tree and other FamilySearch services through their API. And all of these agreements, all these partnerships have something in common. GEDCOM X is the data exchange mechanism. I'm going to share a little bit about GEDCOM X, including the vision and the scope and the plan moving forward. I'd like to start by sharing a little story that happened about 25 years ago when a group of researchers got together to do some research in Switzerland. They all had a big project, there was a lot of data to do, and so they split it up, and in the end they came off with a lot of research and a lot of data on floppy drives. The problem was that time ran out and they all had to go home. Each of the researchers needed access to each other's pieces of the research in order to come to the conclusions that they wanted to come to. Sharing floppy drives was inefficient. They'd have to mail it across the continent or somehow otherwise get access to the data. What they really needed was access to each other's computers. So not knowing much about computers, they decided to turn to a software engineer, which was awkward at first because he didn't know anything about their domain or anything about the research that they were doing, but he did know a lot about computers. It was also a little weird because he tended to think in ones and zeros. But they knew how to get to him. They offered him some cash and some pizza and some coffee, and he was happy and he started to get to work. What he came up with was threefold. The first part was the URI, the Uniform Resource Identifier, which is a definition, a mechanism of a way to identify a computer. The next thing was HTTP, the Hypertext Transfer Protocol, which was the way that computers would talk to each other when they located each other using the URI. And the third thing that he developed was HTML, so that computers would actually have something to say when they talked to each other. And the World Wide Web was born. The year was 1989. The researchers were actually physicists. The project was CERN. The research was actually on subatomic particles, and the software geek was Tim Berners-Lee. There were a number of different factors that contributed to the success of the World Wide Web. One of them was that the web was well-defined. The specifications that governed the web and how it functioned and how the computers could participate in the web was well-defined. This included specifications about the URI, about HTTP, about HTML. The other thing was that the World Wide Web was really handy. Obviously, these researchers, these physicists, used it to share and exchange data on their research, and it became ubiquitous. It became really useful. It was physics wasn't the only domain. It was applicable across many different domains. The other thing that was a contributor to the success of the World Wide Web was that it was free and open. Unlike the Gopher protocol that the University of Minnesota decided to start charging royalties for, CERN let these specifications, these protocols, be free and open, royalty-free, and engage the community on it. Finally, there were a lot of cool tools that were available, and in particular, we're talking about the web browser. Back then, for the Netscape browser and other aspects, Tim Berners-Lee developed a browser too, a prototype browser as well. But people kind of jumped on board and started developing these tools that everybody could start using. And the tools made the web actually accessible and useful. Today we find ourselves in a really familiar situation, a situation that seems a lot like what these researchers found themselves in. We, in the genealogical community, would like to share our genealogical research with each other so that we can come to the conclusions and help build out and contribute to the understanding of the history of the world. We today use computers to store our data, and we still need software geeks to think about how to connect and share this data. In our context, we can consider the URI a very useful tool, as can we consider HTTP. It's still very valid, and we can still use both the URI to identify computers and HTTP to have computers talk to each other. What I'd like to look at a little bit more closely is HTML. HTML is really useful. Obviously, we have a lot of websites that are available today, FamilySearch.org and Ancestry.com and Find My Past and My Heritage, and many, many others who are using HTML to share genealogical data and at least make it available for users to consume. The problem is that HTML doesn't talk in terms of its semantics are different. HTML talks in terms of documents, fonts and styles, tables, bullet lists, scripts, images. These are the units of semantics for HTML. What we need is some kind of a format that talks about genealogical data so that computers can understand semantically what is being exchanged, what kind of data is being exchanged. We need a format that talks about things like sources and persons and evidence and relationships, analysis and places. GEDCOM X is a format that is designed to be able to do that. And it's designed to be able to integrate nicely with the other web technologies and other technologies that we've had and have developed over the past 25 years. So let's consider the success factors that are applicable to a protocol, to the data format. First of all, GEDCOM X is well defined. GEDCOM X is defined by a set of specifications that include the date model, the conceptual model, the XML format, the JSON format, and the file format. The date model is a specification that defines how to exchange genealogical dates, because in our space, genealogical dates are especially important and have some specific requirements about dates. And we need to make sure they get accounted for. And we found that the existing specifications out there were a little inadequate. So the conceptual model defines the semantic units, the sources and personas and persons and relationships and whatever the units of these data types that we want to exchange. The XML format specification talks about how to serialize out those concepts into XML, and the JSON format defines how to serialize out those concepts into JSON. The file format can also be thought of as a container format, which is a way of bundling up a bunch of data, perhaps particularly like an XML document that contains the GEDCOM X data types and serializes out those data types, and bundle those up with things like images or other types of resources that we want to be able to exchange in a single container. There are a couple of other specifications that are currently a part of the GEDCOM X project. This includes the RS specification, which defines how to define a web service interface for accessing genealogical data over the web, over the World Wide Web. There's a record model specification, which defines certain specific aspects to exchanging field-based record data. So, for example, when we're extracting data from an image, we want to record it as we see it, and so we kind of split up the images into little fields, and we want to record the original, what the image actually says, and then maybe an interpreted value, so that we can interpret what we think the image means to say, etc. So there's a bunch of different data types and stuff that are specific to that kind of data format exchange in the record model specification. And then there's another specification that's open and being worked on called the bibliographic metadata. That defines bibliographic metadata, such as the units of citations, author and publication date, etc., that we need to be able to exchange as well. The RS, record model, and bibliographic metadata specifications are still under development, but the first 5 specifications were the ones that were included in the Milestone 1 release back in June. This is an example of GEDCOM X date format. On the left, we see a description of a date, English description of a date. This is how it's encoded in the GEDCOM X date format. We have simple dates, date ranges, open-ended date ranges, approximate dates, and approximate date ranges that are included in the date format specification. This is a really, really simple example of GEDCOM X XML. We have an outer GEDCOM X element that wraps the data types that are inside of it, just like the HTML element wraps all of its data types and data elements as well. So here we have 2 persons that are related and that cite sources, some sources. Like I said, this is really sparse. I had to fit it into a single screen. And there's a lot more detail that's associated with each of these data types. This is the same in JSON, example of the JSON specification. GEDCOM X RS provides the same. This is an example of GEDCOM X RS. What we see here is some extension elements in there called links. And so basically GEDCOM X RS is a specification that defines how you could make a web service request and get back a GEDCOM X document that includes links to other things. So if this is a person or a collection, you can see links to the request that you would make in order to get to the parents of that person, or to the children, or to the spouses. Or if you have a collection, you'd want to be able to search that collection for persons, or add a person to the collection, or add an artifact like an image or something to the collection. So GEDCOM X RS is defined in a way that, in a very basic way, enables us to write a screen scraper for genealogical data that is returned in GEDCOM X format. So GEDCOM X is well-defined, or we're trying to get it well-defined as we modify and shape up and get the specification set more mature. GEDCOM X is handy. It's being used by everybody who is accessing the Family Search APIs, and will be used to exchange data, and is being used today to exchange data between the major partnerships that we have, including Ancestry, MyHeritage, and Find My Past. GEDCOM X is free and open. It includes free and share-friendly licenses, royalty-free. Feedback and participation is encouraged. And we are actively developing a bunch of code libraries to make it easy to be able to read and write GEDCOM X data. It includes libraries for Java, C#, JavaScript. We plan on initializing libraries for PHP, and C, C++, and Objective-C. There's also talk about developing a technology compatibility kit, or TCK. You can imagine having a set of libraries that you run against a GEDCOM X file or a GEDCOM X API, and we run this test against it to make sure that it's compliant to this specification. These code libraries are under development. We're actively encouraging participation. We'd love you to contribute and to help get the tool set more developed. A lot of people ask themselves, should I use GEDCOM X? Here are some of the reasons that people give themselves or come up with for not using GEDCOM X today, or some of their first impressions, and I'd like to address some of those. First of all, people tell themselves that it might be too heavy. There's too many data elements, there's too much XML, there's too many other things in there. Well, I'd like to point out that HTML itself is much heavier. Last time I checked, there's about 90 or so HTML elements that are defined, about twice that many HTML attributes that are defined, making a grand total of about 270 HTML elements and attributes that are out there. Those of you who don't know what the HTML BDO element, the HTML del element, ISIndex element, KBD, SAMP, var, all of these are well-defined HTML elements, but I don't know what they mean, and I don't use them very much when I develop HTML. So HTML is really heavy, and HTML is a lot heavier than GEDCOM X is, but you still wouldn't choose anything other than HTML when you're trying to publish a web page. You don't want to come up with your own data format that might be slimmer or less complicated. You use HTML and you use the elements that you actually need in order to get the job done. GEDCOM X is much the same way. First of all, I don't think GEDCOM X is as heavy as people say it is. It does have a lot of requirements. We've tried to identify as many as we can, and we've needed to meet all of those requirements. And so it's not simple. It's not overly simplistic. It's only as heavy as it needs to be in order to meet those requirements. But just like you do when you program HTML or write an HTML web page, you only need to use the elements that you actually need. Use the elements that you have in your data model, the elements that you want to exchange. A lot of people consider that GEDCOM X might be missing one of their features, one of their favorite features, missing this or missing that. Well, there are a couple responses to that. You're welcome to use the extension mechanism. GEDCOM X has a well-defined extension mechanism where you can put custom elements or things like that. Family Search APIs are using the extension mechanism to, for example, exchange things like discussions. GEDCOM X doesn't have a definition for a discussion, but we want our partners and affiliates who are using our API to be able to read discussions and comments on those discussions. And so we're using discussion and comments as extension elements to GEDCOM X. The other option that you have is to contribute to the project and propose additional enhancements and feature requests. We are committed to preserving backwards compatibility with milestone 1, but we are always open to adding new elements to the specification set and would love to hear your ideas. So help us fill in those holes. A lot of people look at GEDCOM X and say, well, I've got this data model that I want to be able to serialize and share with others, and I can do better myself. I don't need to go learn someone else's data format. Well, you probably can. I wouldn't be one to argue with you. You could write a much more efficient, much more simple, much more streamlined data format that would fit like a glove to your data model, and do better than GEDCOM X, and try and fit your element, rather than trying to decide where your elements in your data model fits in this exchange mechanism. You could also do better than HTML. I think that HTML is kind of noisy. I think there's a lot of elements in it. I think that I could define, if all I really need to do is be able to show tables and images and italicized and certain amounts of styles, I could come up with a data format or a document format that's a lot better than HTML to do it. But that doesn't mean I'm actually going to do it. HTML is a lot more ubiquitous. It has a lot more success. And there are a lot more tools out there that read HTML. And if I'm actually publishing a web page, I'm not going to make someone develop a client or a tool that reads my special custom document format. I'm just going to use HTML and let them use the tools that they're already familiar with. Remember the success factors before you go off and develop your own specification or own data format or serialization mechanism. Do you want to write all the docs and keep those up to date and maintained? Do you want to curate all the specifications? Do you want to develop the tool set and the libraries that read and write those things? Because all of that is an important aspect to making sure that your data format becomes a success. The alternative is to use GEDCOM X and leverage the specifications, the documentation, and the tools that we are actively contributing to and making better every single day. One of the other things that people note about GEDCOM X is that it's not owned by a committee. And I will be the first to agree with you. It is not owned by a committee. This is developed and maintained and curated by Family Search. I'd also like to point out that the World Wide Web also wasn't owned by a committee. It was developed at CERN by Tim Berners-Lee, but it was free and open, just like GEDCOM X is free and open today. The tool set needs work, and I agree with you there too. But rather than shying away from the work that needs to be done to develop the tool set, I'd encourage you to reach out, find the holes in the tool set in your library of your favorite language, pitch in, provide feedback. Don't pass up the early opportunity to contribute to this project and to help this genealogical community move forward. We can rally around this, and we can all make a difference. And that's the invitation that we have to you. Pitch in, get in early, contribute, and make a difference. As I look over the past year and consider the progress that we've made, I'm pleased with the agreements that we've been having and the inroads that we've been making and the progress that GEDCOM X has been making as we exchange genealogical data with our partners and with the industry as a whole. There are some things that I'd like to do better as I look forward to 2014. This includes being a little bit more actively involved or actively publishing the blog entries, making sure that the blog, creating a little bit more noise, creating a little bit more motion, inviting more people to participate, using the user list that's been out there to find that is totally inactive and doesn't have very many posts there at all. I'd like to make some posts, and even if at the beginning, even if it's just posting into the blind, so that I can keep people up to date and that we can make sure that people know where they can contribute when they want to contribute, and can identify and where they can make those contributions. I'm looking forward to 2014. We've got a lot of work to do. Again, we'd like to invite you to participate. We'd love your help. Thank you very much.